Good morning, everybody, and welcome to this info session. My name is Manuela Tiramani, and I'm the head of the Pesticide Peer Review Unit in EFSA. Welcome to this event. As you see, I'm in my home office and I cannot join you today. Apologies for this, but I wanted to be here with a welcoming message. Why this info session? Applicants today submitting application for the 1107 or the 396 are requested to submit information on metabolism as attached to a Euclid and generated with the MSS composer, which is part of the MetaPath software. 2 years ago, we've had a previous webinar with the applicant to explore these functionalities. And now today is the turn of member states. We are here with you. And the purpose of the meeting today is to learn how to review, validate, and ensure the necessary quality standard for the information provided. Why? If you consider that now, for instance, for an MRL opinion, at the end of the assessment, the XML information will be placed in the EFSA MetaPath database, and as such will be publicly available. And this is extremely important because everybody could see it, could reuse it. So this is great on one side for transparency, for limiting the use of studies, and on the other side has a lot of issues to be solved. Of course, with the increase of the number of XML files, also your questions will increase and are increasing, so it's important that we are prepared to deal with this. I'm very happy for this achievement because for instance, already US EPA is making use of the EFSA MetaPath database for preparing the chemical transformation database, which is such an achievement also in terms of collaboration, partnership, not only at our EU level, but also with other organizations. So that's very important because we all want to look for, are looking for data, want to reuse data, want to share. And I think this is absolutely an important step forward. Let's also think that there are other projects upcoming. For instance, with the OECD on the new assessment methodology, NAMS. I think most of you know that NAMS is one of the key words for the next years for the work of all of us. And so it's very important that also the MetaPath database can provide a piece of information support in the development of these activities. So extremely important. So quality of the data is essential, and today we will try to see how we can guarantee this altogether. I mentioned several times MetaPath database, and with regard to this, I would like to express my gratitude to the colleagues from BFI Analysis who have worked in the last years to build this database. Thank you. Your contribution was essential, and thank you very much. And also, for those of you who are not familiar, you can find the database in our website, in the EFSA website, together with tutorial manuals, so you can start practicing and learning, unless you are already familiar. As for the info session today, I also want to say thanks to the colleagues from ANSES who are collaborating with us for this event through a tasking grant, and special thanks to our 3 super users, Gael, Opaline and Charlotte, because also their support is very important also for the success of this event. And I also want to say thanks to our colleagues from the course unit in EFSA to the support for the logistical aspects, and also to Anya and Herman, who have pushed me in preparing these and gave me a lot of enthusiasm for this event. So very good also for your determination in achieving the result. Thanks a lot. And now a couple of practical questions. So I think now we are all familiar with this. You can put your question in the chat and the colleagues from Answers will take care of replying to them in the question and answer session. Should any of the question be left out because of time constraints, for instance, there will be written answers. So we hope that we can cover as many questions as possible. And so now it's time to start the info session. So let's start with my general discussion. I wish you a successful event. And now I hand over to Gael. Gael Vial is the Deputy Head of Unit of the Pesticide Residue and Food Safety Unit in ANSES. So Gael, the floor is yours. Thank you very much.
So, good morning, everyone. As Manuela said, I am Gael Vial, and I am very pleased to start this webinar on MetaPath and on more precisely on how to validate MSS composers for pesticides metabolism studies. Even most of you are already aware of this. I will very briefly remind the main goals of MetaPath, what is MetaPath and what has been already done on MetaPath. Then I will introduce the agenda of this morning. So first, why MetaPath? As you know, in the framework of pesticide assessment, several kinds of metabolism studies have to be submitted to investigate the fate of active substance in rat, plant, livestock, rotational crops, and so on to identify the relevant metabolites and then to define the residue in food and environmental compartments. Today in Europe, and I have checked a few days ago, there are more than 450 approved active substances, which represent more than 3,000 metabolism studies. And until a few years ago, there was no tool to easily identify common metabolite to several compounds. Indeed, depending on the laboratory, the company, etc., the same metabolite could be named differently. This observation conducted in 2005 to the development of MetaPath by US EPA and the Laboratory of Mathematical Chemistry of Burgas in Bulgaria. So what is MetaPath? It's a database on pesticide metabolism, which can contain all the metabolic pathway for all the active substances. The database contains the experimental condition, the result of the metabolism studies, and allow comparison of chemical structure, search for common metabolite, or metabolic profile comparisons. Indeed, MetaPath is made up of two modules. One is the MSS composer, used to fill data from metabolism study, and that could be registered as XML file. For now, there are 4 composers, one for metabolism study on plant, one for livestock, one for rotational crop, and another one for rat metabolism. But today we will focus on the first 3. In each composer, there are several tabs. For example, materials and for example, tabs for materials and method, for information related to the protocol followed in the study, other tab for the result or for describing which compound were found in which matrix. And as you probably already know, there is an internal drawing tool to draw molecule, which is very powerful to draw at the end metabolic pathway. Then the second part is the MetaPath database, in which the MSS composer as XML files have been imported or could be imported, and which allow to display metabolic profile and all results of each study. The software contains tools, as I said, to be used to identify common metabolites or, for example, to compare metabolic pathway. As I said before, the project MetaPath was initiated by US EPA and the LMC, and then with also the effort of the MetaPath user group and the OECD, the database was populated through several projects, one with the Canadian Agency on Livestock Metabolism, another with ANSES in collaboration with US EPA. And in 2020, in the context of the transparency regulation, EFSA launched a project with BFR and ANSES on incorporation of more than 1,200 maps in the database. This project, coordinated by EFSA, was a collaboration between BFR for data extraction and entry, between ANSES for quality control and database creation, and the LMC for the software development. In the framework of this project, more than 1,200 maps were coded for a total of 170 active substances. It represents more than 600 maps for metabolism in plant, near than 400 in rotational crops, and the rest for livestock. Databases have been created with all the validated maps, and the sanitized database is already available on EFSA website. So today, a big effort has already been made to populate the database and has to be continued to keep it up to date. So to conclude this short introduction, as you understand, MetaPath is a software which allows to identify common metabolite, chemical structure, similarity through metabolic pathway of different active substances. It will serve in hazard identification and in mutualization of the work between regulatory agencies. And now, in the context of the transparency regulation implementation, it was agreed that the data on metabolism generated with the MetaPath composer software should be submitted as part of the IUCLID dossier by the applicant and to be validated by the RMS. So that's why today we will explain how to do this, and especially how to validate MSS composers for plant, animal, and rotational metabolism studies. So we will present the general workflow validation, how to open XML file in MSS Composer, how to import them in MetaPath, adding regulatory ID, how to check the XML file, and after the coffee break, we will continue with the main coding errors during the import of XML in MetaPath, how to report error and modification. We will watch with you short videos on other way to display and check information, and then we'll close the meeting after the Q&A session. Now I have talked quite a lot about generalities that most of you already know. You probably looked forward to get to the heart of the matter. So let's start with Opaline, who will speak about the workflow validation and the versioning of the different documents.
Thank you, Gail. So as Gail said, I will keep going with the general workflow validation. As you can see, it will be a quick presentation. So here we go. The first question of the general workflow is, has the applicant supplied the XML file relative to the metabolism study? If you have to see a metabolism study, it means that the applicant needs to provide an XML file. So if it's not the case, please ask the applicant to supply the XML in Euclid. But if it's the case, we can go to the second question. Please note that the map can be already available in the authority database. In this, there is the EFSA public collection of maps. This collection of maps is regularly updated with new entries, and users are therefore invited to check the list frequently. So even if the map is already available, it needs to be applied, it needs to be provided in Euclid. So if it's not a new map, a new XML file needs to be provided. And if the map is already available in the authority database, a new XML file is not requested. However, the applicant is required to report the already available map. The second question is, can the XML file be imported into the MetaPath database without any errors? Indeed, when you try to import the XML file in the MetaPath database, you will have a message, and this message can be this one XML file failed to import. If it's the case, please send back the XML file to the applicant with the detailed log report. The detailed log report is a report which is created by MetaPath and that explained what errors comes. If the XML file is successfully imported, you will have this type of message, and you can go to the third question. The third question is, can the errors be easily fixed? For that, you will need to create a new version of the XML file, open it with the MSS Composer, read the study report, and check if there are some mistakes in the XML file. You can create a quality assessment report. In this document, you will write all the errors that you found and all the corrections that you've done. If the errors cannot be easily fixed, please prepare a request indicating issues and solutions that are identified. But if you can easily fix the errors, please fix them. Modify the XML file and report your modifications in the quality assessment report. This step is the major one. You will use some documents to help you, as the MSS advisory notice and also the process steps for metabolism data. And of course, you will need the study report and the adequate MSS composer. So you will check the accordance to the conventions of substance characterization for MetaPath. You also check if all mandatory fields are compiled. Check the accordance to the naming conventions for maps, treatment groups, objects, matrix for MetaPath. And you will also check if there are some bugs, if the metabolic tree is correct. It means that the chemical structures, the relationships, the distribution of compounds among treatment groups are corrected, and if the results are corrected. We will go in details later during this webinar. We propose the file versioning. So the first version sent by the contractor can be named V1 because this is the first one. And when you will review this XML, you can name it V2 and so on for the following file versions in case of additional file exchange. And if you code the final version, you can name it VF. Please note that if modifications are made, you have to not forget to check the importation of the last XML in MetaPath. Why? Because if you do some corrections, maybe it will lead to an importation error in MetaPath. So you need to check at the first step, but also at the last step. So as a conclusion, here is the general workflow. The first question is, has the applicant supplied the XML file relative to the metabolism study? Even if it's a map which was already coded, the map needs to be provided. So if it's not the case, please prepare a request. If it's the case, you can go to the second question. The second question is, can the XML file be imported into the MetaPath database without any error? If it's not the case, you need to prepare a request. If it's the case, you can go to the third questions. Do the errors can be easily fixed? Again, if it's not the case, you have to prepare a request. But if it's the case, if no substantial defects are identified, you can modify the XML file and report your modifications in a quality assessment report. And if modifications have been made, you need to check the importation in MetaPath. So here it is for the general workflow. And now I will give the floor to Charlotte. Thank you very much.
Charlotte, you are muted.
So thanks to Opaline again, and welcome to everyone. So now you can imagine that we received the XML in Euclid, and we will learn how to open this XML file in the MSS Composer. Then we will talk about regulatory ID. We are related to the study or to the compound, and then how to import your XML in MetaPath. So as Opaline and Gal said, we have 3 MSS composers for crops, livestock, and plants. And I will show you how to open the XML file in the MSS composer. So first you have to choose the good MSS composers. Here I choose the MSS for plants, and that's what I look like. So if I want to open an XML, I click on Open. Then I choose the good file. It is the V2 version. I click on it and then on Open, and the XML file open. On the first page, you will see the general information with the authors of the study, the date, the study title, but also 2 identifier spots, and I will explain what are these identifiers. So there is 2 types of identifiers. One is related to the study and one related to the chemical compound. The first identifiers here is related to the study. So this is the number of the study, the number linking to the study. And here, the second identifier is the one related to chemical compounds, so the substance of the study. The second identifiers are a mandatory identifier, so you have to fill in this information. But before to filling this information, you should have to manage the ID. Everything I will explain you now is writing in the MSS advisory notice, so you can find all the information. So how to manage the regulatory ID? First, you have to open the regulatory ID managers, which is available in Option and Manage ID. Then it brings up the following editor. The top list contains all the available identifiers. The regulatory library is pre-populated with the following identifiers: master record identification numbers, pest management regulatory agency, pesticide chemical code, and other code. Then you can manage it. So to manage it, you can click on the first one, for example, and it displays all the property in the panel below. You already have the caption. Here it's MAID, but also the agency and the description. You have to be careful because 2 ID cannot have the same caption and agency. So here you also have the checkbox. Checkbox are show in citation and show in general information. Show in citation is that if you click on it, is that your identifier is linking to the study. The second, show in general info, if you click in, it's that your ID is related to the substance. To edit an identifier, you can select it from the list, make your changes in the property, for example. So here I had test for webinar, and you can click on update to update the modification. You can also delete an identifier. You can select it from the list. You see the description has changed, and you can click on delete to delete it. Remember that to save your changes, you have to click on, and you also can click on cancel if we don't want to keep your changes. The last thing that you can change is to add an identifier. For example, a param code. The param code or parameter code is a data element used to describe a substance analyzed. It can be the parent, the metabolites, or several metabolites included in the residue definition for monitoring or risk assessment, for example. So you have one added to fill the property. So you can fill the property, the caption, the agency, and the description. Then you can tick the good checkbox. Here I click on show in general info because it's param code and it's linked to substances, and click on add. The param code was added in new regulatory identifiers, and again, to save my change, I have to click on OK. The editor only manages the properties of the identifiers, but does not change the value. So you also have to enter the value, and I will describe you how to do this in the next section. So now my list is complete. I added 2 regulatory identifiers, PC code and param code. These 2 identifiers are related to chemical compound. You have to know that param is mandatory and PC code is available. So once my list is complete, I can enter the identification value in a related section. Now, how to edit these identifiers? So I remember that you have 2 identifiers, one related to the study. So the checkbox was ticked for show in citation, and for identifiers here, they are related to the chemical compound. So I ticked show in general information, and again, these ones are mandatory. So to edit the identifier related to the study, I just have to click on Edit. This brings up the following editor, and the left list contains all available identifiers from the manager's ID, which are related to the study. So first, to add identifiers selected from the list, click on the arrow. It will add the selected identifiers, and you can now fill in the value. So here I had the value identification study test for webinar. And again, to save your change, click on OK. Your identifier will appear in the first part. To edit identifiers related to the chemical compound, do exactly the same with this identifier. So click on Edit. This brings up the following editor with all the identifiers related to the compound. In the same way, identifier and fill in the value. So click on the identifier, add it with the cross, and fill in the value. Here I add a value of param code. This param code can be found and downloaded from the EFSA catalog browsers that you can find on this link. And I will add also the PC code in the same way. I will fill the value and then click on OK to save my changes. So as you see, the 2 identifiers were added. Here you see that the param code was left blank. You can't let an identifier blank because it will lead to an error of importation in MetaPath. I will show you more in detail this problem, but here you can't leave empty. So edit it and fill in the value, or you can also delete it and click on OK. But as I said before, the param code is mandatory, then always fill in as possible. So now here you see that there is just a PC code and the param code disappear. Now I will let you hear a small video on how import XML in MetaPath, because we have changed all the identifiers and we will check if the XML files is able to be imported in MetaPath. So
in this video, we will explain how to import an XML in a database in MetaPath. To import an XML in a database, This database has to be loaded in MetaPath. The previous video, chapter 1, shows how to open MetaPath and load a database. Also, make sure that the XML file is saved on your computer. A data file with an extension .xml is needed. Click on File, Import, Import MSS XML. The window Select a MSS XML opens. Select the network location where the XML file is saved. Click on the files.xml and on Open. A second window appears, asking you to confirm the importation in the database. Click on Yes. A new window appears, which indicate that importation is in progress. Wait a few seconds. A last window appears and indicates to you if your XML files were successfully imported or not. If the importation is a success, you can click on Ignore if you don't want to see the import log. If you click on No, a note named MSS XML import log appears. As you can read, the current MSS XML was imported successfully. Close this window. The XML file is now imported in the database.
So as you can see, the XML file is imported, and now you know how to open an XML in the Composer, how to manage the identifier and fill in the identifier, and how to import the XML in MetaPath. Some key points to finish. The param code is a code created by EFSA and used to describe a substance analyzed. This code is mandatory identifier. If the value of a selected identifier is blank, it will lead to an error of importation in MetaPath, so always fill in the identifier or delete it. If the identifier have already been managed by the applicant, you just have to check the value and correct it if needed. And finally, you have to report all changes in the QA reports. Thank you. So now I will give the floor again to Opaline. She will see you how to check the XML.
Yeah, thank you, Charlotte. So as Charlotte explained to you, I will now show you how to check the XML files. So here we go. For an introduction, I just want to explain to you what is an error, because an error can be different type of things. It can be a mandatory section that is not filled. It can also be an information that differs between the study report and the XML file, an information or a result that is not reported in the XML file, or an incorrect way to report the data that leads to an error of importation in MetaPath. What is the goal of this check phase? The goal is to correct the errors, but it is not to indicate opinions on the study. It should therefore not contain any assessments and opinions by applicants, but also by regulatory authorities, but entries be restricted to the information reported by the study report, the study author. Now I will show you the material which is needed to check the XML file. So we need the study report, which is available in Euclid. We also need the XML file, which is also available in Euclid. The adequate MSS composer. So here in this example, the study is on poultry. So it means that I need to use the MSS livestock composer. But if I had a study on primary crops, I will use the MSS plants composer. And if I have a study on rotational crops, I will use the MSS crops composer. I also need the MSS composer's advisory notice and the process steps for metabolism data. These documents are really useful because they explain how to field the different sections in the MSS composers. So when you check the XML file, it's really useful to use these documents. Of course, we need MetaPath. As you remember, we need to check if the XML file can be imported in MetaPath. And we can use a qualitative assessment report, a QA report, when we will write all the mistakes, the errors that we found, and also all the corrections that we made. So now we know what material is needed. I will show you a little bit what sections are present in the MSS Composer. After, I will show you some examples of mistakes that we can find in XML files. And at the end, I will try to show you a real example in a live session. So first of all, in all the MSS composers, we will find the general information. Here we need to check all the information, and please do not forget to check the param. Charlotte explained to you what is the param, and she said to you that you can modify it using the button Edit. The second section is Material and Methods. You will find two subsections, Materials and Study Design, and of course you need to check both of these sections, Materials and Study Design. The section 3, Results and Discussion, you will find here different subsections. A, total radioactive residues. B, extraction, characterization, and distribution of residues. C, storage stability of residues. D, identity of residues in crops. And E, proposed metabolic pathway. You need to check all these sections. Here you can note that in the section Materials and Methods, you can find multiple radiolabeled test materials. And if multiple radiolabeled test materials are entered in this section, you will find various tables in the section 3B and 3D. So in this example, you can see that there are materials for two types of labeling, triazine and pyridine, and there is also a label for low dose and high dose. So here, as you have 4 types of materials, you will find 4 tables in the section B and 4 tables in the section D. Please, you have to check all these subsections. In the section E, Proposed Metabolic Pathway, at the beginning, you will not find any metabolic map. For that, you need to click on the button Build Metabolic Map, and you will have the metabolic pathway. You cannot correct the metabolic pathway using this section E. For that, you need to use the Appendix 2. So I will explain later how to correct a metabolic pathway. In the conclusions of the study report need to be reported. As I said before, the opinion of the member state doesn't have to be reported there. And in the appendix, you will find 3 types of appendix, Appendix 1, 2, and 3. There you need to check a lot of data. First, with the Appendix 1, you will find here all the matrices that are analyzed in the section 3D. You will see the application method. So in this example is a foliar spray application, the application rates, the number of application, the timing of applications, the post-harvest interval, the matrix, and other information like the test crop and the soil type. All this information need to be checked with the study report. In the Appendix 2, you have to check the molecular draw of each molecule. For that, you can double-click on each molecule and the Appendix 2 editor will appear. There you can compare the draw with what is found in the study report. In this example, the molecule is correctly drawn. In this Appendix 2, you will also find who is the parent of who. So for this metabolite, the second one, you can see in this column that the parent is 1, 3, and 8. And if you double click on this molecule, the Appendix 2 editor will appear and you can check and correct with this table who is the parent of who. So if we check in the study report, you can see that this is correct. The parent of this metabolite is the molecule 1, 3, and 8. You also need to check the expertise in this part of the Appendix 2 editor. So if you click in the molecule, you will have this Appendix 2 editor, and you can see there that it is written that the conjugates are in an unknown position. And this is right. We found this information in the study report. You can also check in what matrices are found the metabolites with the table treatment groups. In the Appendix 3, the table is automatically filled. Be careful, please, because this is really sensitive. So you will see in the live session why I am saying that. And so we strongly recommend updating this table using the treatment group fields of Appendix 2. So there you can correct in what matrices are found the metabolites, and the Appendix 3 will automatically be corrected. So here is a conclusion for appendices. In the Appendix 1, you need to check all the data. In Appendix 2, you need to check the draw of each molecule, also the links between each molecule, check the expertise, and in order to correct the Appendix 3, we strongly recommend to use the Appendix 2. Now you have here a short video that explains a little bit more how to correct the draw of a molecule.
Appendix 2 of the MSS composer. In the Appendix 2 are reported all metabolites identified in Section 3, Results and Discussion, D, Identity of Residues. In order to correct the Appendix 2, click on the molecule. A new window appears. You can see its common name, its chemical name, its SMILES code, its draw, who are the parents, in what matrices it was found, and the expertise. All these data need to be checked and, if needed, corrected. In order to correct the molecule draw, you have to click on the pencil. Then, you can correct changing the draw of the molecule. You can also correct the structure through the SMILES code. In case no residues are identified in any matrices, for example because TRR were too low, report at least the parent. Indeed, if no molecule is listed in Appendix 2, the map is not imported into MetaPath.
So now I want to show you some examples of errors. So maybe you remember an error can be a mandatory section that is not filled. In order to know what are the mandatory sections, you can use the MSS Composer Advisory Notice, but also the process steps for metabolism data. In this document, Process Steps for Metabolism Data, you can see here that the common name and the Cas chemical name are mandatory. However, in our example, they are not entered in the MSS composer. So we need to correct that. No, we need to correct that. Sometimes a mandatory section that is not filled can lead to an error of importation in MetaPath. So in this example, you can see that no param is entered, and that leads to an error of importation. So Charlotte will explain later what type of errors that we can find in the part import in MetaPath. An information that differs between the study report and the XML is also an error. So in this example, you can see that they enter the date 2006 instead of 2007. So this is an error. We need to correct it. This is another type of error. Here you can see that in the growth stage at application, the applicant writes 0 point not applicable. However, in the study report, we know that the potato plants 40 days after sowing were treated. So even if we didn't find the BBCH stage, we prefer to enter 40 days after sowing because it was more precise. So we correct the XML file. Here is an error that we can find a lot because there are many tables sometimes in some XML files. So in this example, you can see that in the table the identity of residues in ruminants, for this metabolite, they wrote that it was found at 7.08% of the TRR. Unfortunately, in the study report, this is 7.98, so this is a typo error. And please, tables in the DAR or the RAR must be in line with what is written in the XML and the study report. Here you can see that this is the same example that we found in the video. This is a problem of representation. So the metabolite that was drawn in the MSS composer was not the correct one. So we had to correct it using the 2D editor. An error can also be an information or results that is not reported in the XML file. So in this example, you can see that only 3 molecules were identified in the Appendix 2. However, in the study report, 5 molecules were identified. So we wrote in the quality assessment report, please update Appendix 2 according to metabolic pathway proposed by study author. These compounds are missing. And of course, an incorrect way to report the data that leads to an error of importation in MetaPath is also an error that you can find. So now I just want to show you a real example with a live session. So for that, I need to stop the slides. So I will use this study report, and maybe you remember the first step of the general workflow is to check if the XML file is provided. So in my case, the XML file was provided, and now I need to check if I can import the file in MetaPath. So for that, I need to find the XML there. So you can see that this XML file was successfully imported. So for the second step, this is okay. I already have quality assessment reports. So there, I already wrote the name of the XML file, and I can say that, yeah, the importation is okay. And now I have to check all the map with you. Of course, I will not read all the study report with you because I think it will be a little bit boring to do that in live. So I already know where are the mistakes and I will show you how I will find them. So I import the XML file in the MSS Composer. As you can see here, I am in the general information table. These are great. I can read them in the study report. However, in the test material, you can see that this is not the correct, this is not the name of the molecule. This is the company name of the molecule. And if I'm checking in the user guide, I will see that normally I need to have other type of information in general information. Here, I need to find the common name of the active substance and, if available, the company experimental code in brackets. So I have to correct that. I can check in the materials and method if it's well written. Yeah, this is well written because I have the common name there and I also have the company experimental name. So here I just have to add the name of the active substance. And I put in brackets the company experimental name. Of course, if I have a quality assessment report, I can write the information in my quality assessment report. And now, as I modify the XML, I will save it with a new name. So as this is the second version, I will name it V2. So I will keep going to check all the information. I can go in this part, materials and methods. Normally, I have to check everything. Here, you can see that there is tomatoes solanum. This is right, tomatoes are solanum. However, the information needs to be completed according to the OECD number 501 for the crop group. So for tomato, this is fruits. And we prefer to put this information in singular. So I will write tomato. And I also will write fruits. And of course, I will add it in my quality assessment report. Here, tomato fruits instead of tomatoes solanum. Okay, we can keep going to check the information in the section B, but also in the section 3, A, B, C, D. As you remember, I said there are a lot of, we can find mistakes in this type of tables. Sometimes it's typo errors. So we need to really check the data that we found there. Here you can see that there are 2 labels. So of course we need to check the data for these 2 tables. There I can see that there is an information which is quite different in comparison of the others. So I will check in the study report if it's the correct one. I already know where is the information. So here for whole tomato bound, whole tomato bound, I can see that, yeah, this is 0.2, but 0.2 ppb. However, in this table is the data are entered in ppm, so I have to modify that. And of course, I can write this information in my quality assessment report. There you can see I changed the 0.2 and I put 0.0002 because it was in ppm. Another type of error that we can find can be in the appendix. I need to check if all the information is entered there. I can count the number of lines. 1, 2, 3, 4, 5, 6. I have 6 lines, so 6 matrices, type of matrices. And in the results and discussion, there I have 3 columns and 3 other columns. So all the lines are entered. However, here you can see that the applicant forgot to enter some data, so I have to add the information. For the application rate, I read the study report, so I know that this is 50 gram active substance per hectare. For the past harvest interval, this is 14 days after last application. The number of application, this is 1, and it was whole fruit. So I corrected this line and I put the information here in my quality assessment report. Then I have to check the Appendix 2 and the Appendix 3. So in the Appendix 2, you have all the metabolites that are identified. Here you can see that they say that the parent of the DTPP was flazasulfuron. So I need to check this information, finding the metabolic pathway in my study report. So I know that my metabolic pathway is in page 68. And there I can check that the DTPP is an intermediate, but the parent of this compound is not flazasulfuron. This is DTPU. So I can correct that double-clicking on the metabolite, and here I can change saying that the parent is DTPU, and I submit the information. So now you can see that the information has been changed and the parent is not anymore 1, but is 4. And here in this Appendix 3, you can find all the metabolites and all the matrices. And for example, in this line, it means that the parent was only found in this matrix, which is the tomato whole fruit in low dose. So I can check that. Here I cannot find the parent and I cannot find the parent. So this is a wrong information. I can correct it just clicking there. But the problem, as you can remember, is that the Appendix 3 is really, really sensitive. So if I use my mouse above that, I can change the information, but this is not my wish. So that's why I prefer to change the information using the Appendix 2. So for that, I have to double click on the molecule that I want. This is the parent, and I can just remove there that the parent was found in this matrix, and I submit the information. So I did all the corrections. Of course, normally I have to read all the study reports and check everything. So as I did these corrections, I have to put them in my quality assessment reports. And now I have to save that. And of course, because I did some modifications, I have to check if I can import the XML file in MetaPath. So File, import MSS XML. This is the V2. Open. Yes. And the XML file was successfully imported. So this is a great news. It means that now I can name this version VF because I don't want to send it to the applicant, because for me the errors can be easily corrected. So that was the end of my live session. Now I just want to show you a short video showing you that we can draw positional isomers in the MSS Composer. The applicants can do it. This is a little bit complex, but I think it can be really interesting to know how to do that. So here we go.
In this video, we will see how to design positional isomers in the MSS Composer. First, click on the adequate molecule in the Appendix 2. The editor appears. Click on the pen. The 2D editor appears. Click on Common Fragments. When clicking on the button New, a new window appears. You can select the type of common fragment you want to create. In our example, we choose positional. Positional fragment is used to generate positional isomers. It poses equivalence among a set of atoms and/or fragments. The positional fragments could be connected at a number of positions in the molecule. Name the future positional fragment that you will create in title. In the tab Connections, select the type of bond between the positional fragment and the fixed core. In our example, we select a single bond. Finally, click on OK. As you can see, positional type fragment appears in the library. Click on the button Atom Tool in order to select the appropriate atom. In our example, we select the oxygen. Then, left-click on the FVal button. This tool allows to define connection points in the common fragments. Right-click over the oxygen atom and select Single Bond. Single bond is created. For the moment, the atom is not linked to a core. Click on the button to explicitly specify hydrogen atoms and left-click over the oxygen atom. Left-click on blue space over the name of the positional fragment. Right-click and select Add Struct to add the hydroxyl group to the pos frag. The hydroxyl group appears. The fragment is ready to be attached to the fixed core. Click Save button every time when a new fragment is created if you want to save it. Select Compound Radio button. Now you can see the metabolite chosen in the beginning of this video. Single left-click on Positional Type Fragment. The fragment is now selected. Hold the left mouse click pressed and move the cursor close to the scaffold so the atoms in the benzene ring become highlighted in green. Release the left mouse click to glue the fragment to the scaffold. A new window appears. Define fragment private properties. Select the appropriate fragment option. In this case, Single Connect. In the example box, add the number of times the group will be repeated. If you entered 2, it means the group will be repeated twice. Finally, click on the button OK. Perform right-click over the name of the positional fragment and select Define Connections from the appeared pop-up menu. Initially, all atoms are highlighted in green. Single left-click over the atoms, where the group cannot be attached. In order to unselect them, just left-click over them. Perform right-click over the positional fragment and select Exit Define Connections. Click on OK. Don't forget to click on Submit to save the modifications made on the compound. If the XML is saved and imported in MetaPath, all the positional isomers can be visualized. Right-click over the metabolite and select Display Individual Structures.
So this was the end of this presentation. Thank you very much for your attention. I just want to remind you that if you have some questions, don't hesitate to use the chat. At the end, there will be a question and answer session, so don't hesitate. And the session, I think, will start at 11 and 5. I don't know if it changed. No, it doesn't change. This is the correct timing. So I think the session will start again in 11:05. Thank you very much and see you soon.
So welcome for the second part of this webinar. I will now show you how to import in MetaPath again, and we will talk about the main coding issues, and we'll try to find some solution if you have coding issues. So let's start. As Opaline said, you have to try to import your XML file into your local MetaPath version just when you receive the XML from the applicant, and at the end, after you check all the problems, you have to download it again to import it again in the MetaPath version. So I will show you again how to import the XML file. You have first to open or create a database. For that, you can see the video tutorial chapter 1. Then you can click on File, Import MSS XML. You have to choose the file that you want to import and click on Open. A Windows open asking you if you want to import into current database, and you have to confirm the importation. Wait a few seconds during processing, and a new Windows open confirm you that your XML was successfully imported. If it's a success, click on Ignore. The MSS file is imported in your local database. You can import the files one by one, or you can select several XML files and import them. What to do now if the import fails? As I just said, you can import the file one by one, and here you see that your file failed to import. Here I tried to import 3 files, and 1 is success and 2 have failed. So when you have this failure information, you can click on yes if you want to see the log containing all the imported items, or you can click on no if you want to see only the import error. We will try to click on yes. If I click on yes, as I just said, I receive a log containing all imported items. The first line says you the location or your computer. Then you have all the operations which are a success or a failure. It's a really, really long log because you have every operation. So here I've selected the 3 failure, the 3 operation you failed, but before that you have so much information, and so find all the failure. If it's too complicated, you can click on no and you will see only the imported error. So if I click on no, I have this small log with the same information, the name of the file and this location or your computer. You have also the location of the error on the MSS file. Here, the location is in tier in matrices table maps 1 and indicate you that it's row 16 and column 2. The second error, you have exactly the same information, the location in the MSS file, and the third again. And at least you have the problem. So here the problem is this information, so you see below hello queue, and the software is not able to recognize this cell content. So we will try to solve this problem first. We have 3 problems, and we have to solve these 3 problems before import the XML again. So the first problem was importing tier in matrix table maps 1, and the error was failed to recognize cell content. So we will try to find the table tier in matrices. This table is located in the part C, result and discussion, and part A, total residue, radioactive residue. The table here is named tier in matrices. Here it's X, tissue, and excreta. And if we look at the row 16, it's row 16. I can show you all the rows, but it's 16. And the column 2, you see that we have the cell contents below hello queue. The software is not able to recognize the symbol below following but by letter. You have to rate the symbol below following by numbers, and you have to precise if the LOQ is 0.09 or 0.05. So correct it and change this thing, change the below LOQ to below 0.01 or 0.02, 0.05. And do not forget to report all your changes in the QR reports. The second problem is exactly the same. You still have a failure to recognize the cell content below to LOQ, but it's not located in the same page. It's located in the table distribution of parents and metabolites, always for MAPS 1, but now for radiolabel parents 2. Opaline said you that you could have several parents radiolabel, so you have to find this table for the good radiolabel parents. This table is located in the part result and discussion and part B extraction, characterization and distribution of residue. Here it's the first radiolabel and here the second. So click on the second and find a good table distribution of the parents and metabolites in poultry matrices. The error is located in the row 4 and column 2. And exactly as before, you have to change below LOQ to below N numbers. The third error was exactly the same, located in another location. So here it's in the table identification of residue and it's for radiolabel parents 1. So this table is located in result and discussion and identity of residue in poultry for the radiolabel 1. And the table is named Summary of Characterization and Identification of Radioactive Residue in Poultry Matrices. So you have the same mistakes in row 4, column 3. Make the changes again. When all the changes are made, you can complete the QR report and try to import again your XML in MetaPath. I will try to show you other issues. I already presented you the regulatory identification, and here I have a problem with the value for the MAP1. The parent chemical regulatory ID2 is missing. The text is not available here for parent code. So the value of identifier is empty, and the solution is to edit the identifier, add the right value, or delete it from selected identifier. And once again, the param code is mandatory, so add information if you can. Another issue here in the table summary of storage condition, you have a failure to recognize cell contents below 18 degrees in row 1 and column 2. So find problems and find the location. This table is located in result and discussion and part C storage stability residues. And in the table summary of storage condition, if you look at storage temperature, it's written below 18 degrees. Again, the sign below can be followed that latest only numbers. So just delete the sign degrees. Another issue here, it's in the number of application for MAPS1 treatment group 1. The error 1 space, it's not a valid integer value. So if you see in appendix 1, you will have several information to add, and one of them is the number of application. Here I don't show the maps, but you can't let a space after a numbers. It don't recognize the numbers if there is a space. So just delete the space and correct the QR reports and try to import again the XML. Another issue here. The problem is saving MAPS1 into database lead to a failure, and the error is violation of primary or unique key constraint on table units. This problem is located in the material and method and section material. In the radiolabel test material, you have the specific activity as received and the specific activity of doses. And here you have to give the units. The units here, you have a space again before MCI by millimole. So you can have space and you have to delete this space. Here, another issues, it's linking to the text size. It exceeds the text size characters. So you can't only have 192 characters, and the size of the information was more than 300 characters. As you can see here, it's usually written how many characters you can add in each for each information. So just change it, just delete some characters, and it will be okay. The last issues, and Opaline already showed you, when you receive this problem. So the problem is checking for imported map, operation reached failure, and the error is no maps were imported. You receive this error when the appendix 1 and the appendix 2 is empty. So just complete the appendix 1 and the appendix 2. And again, if your substance is not found in any matrices, you just have to add the parents at least. For a few key points, I think that it's better to follow the advisory notice because you can find some error and their solution. Use the log and the import error. It will help you to identify the location of the problems and the type of the problems. Do not panic, it's usually the same problems and so usually the same solutions. Don't forget to report all changes in the QS reports. The errors may be due to the MSS version, new version or Mothooth. And if you can solve the problems, I think that maybe you should send it back to the applicant. It's the easier if you can solve it. So I think I finish with this presentation, and now I will told you about how to report the changes that you make in the XML. So during the live session, Opaline show you how to use a QA report. At MSS, we created 3 Word documents named Quality Assessment Report. It's a proposition, and we can send it to you the QA report that we created if you want. We have a QA report from primary study, from rotational studies, and for livestock studies. The aim of this document are to detail all modification performed by you, so performed by RMS, and we decided to highlight it in yellow to have a visual see. And we wanted also to add in this document all modification that we request to the applicant. So we highlighted in green. So you can ask to the applicant to make some modification if you are not able to do, and you can make some modification if you can. It's easy. So in this QA report, you have 2 parts. The first part is a general part with the active substance name. So just add the active substance name of the study. And then you have the XML title. You have also 4 questions to be answered by yes or no about XML importation. So say yes if your XML is able to be imported before your modification and also after your modification. You have a question about the correlation of metabolites in the tree with each treatment group. So if the appendix 2 is correctly completed. The render, Gael will show you how to create a render, and you have to check the render also. And the final question is your MSS composer fully validated? So yes or no. The second part is the mandatory field. So we choose to create a table with 2 columns. The first column, in the first column, you will find all the existing fields of the XML file. And each mandatory field are identified based on the list of mandatory field detail in EFSA document named Description of Process Steps of Information Flow. In the second column, you can add your comments. So in yellow or in green. In yellow, if you made the correction, and in green, if you want that the applicant made a correction. So this is a global overlook of the 3 career reports that we created. The first one is for plants, then for livestock, and for rotational crops. You find the first part with the name of the substance, with the name of the XML, and with the yes, the question. And then you find the table with all the fields that have to be completed. The mandatory fields are in green, and the other are are not in green. And you can add your comments in this part. So all changes has to be reported. I will now give the floor to Gaël, who will present you the other way to display and check information. Thank you. Gaël, you are muted.
Thank you, Charlotte. So yes, nearly the last part of this webinar. And this session, we are going to see some tools that are part of the MSS Composer and of MetaPath, tools that can also be used to display and check information. So first, the render tool. In the main top of the software, you have this big word icon with render written. By clicking on this icon, you can create a report. Before, you have to name the file and click on Save. The software will begin to populate a Word document containing all information filled in the MSS Composer. Here you can see a view of the render Word document. So one of the aim of this MSS Composer tool is to harmonize the way metabolism study could be summarized. But for our concern, validation of XML, it could be a way to read and so to check data filled in the Composer. But please keep in mind that XML modification in the Word, the modification in the Word document won't be automatically implemented in the XML file. Another way to display and to check the data filled in the MSS is to export main result of the study as an Excel file. So to know how to do that, watch all together the following videos. I think I forgot to share the sound of my computer, so just a moment, please. Yes, it is.
In this video, we will see how to export tables. You can export all the data from a selected map in a new Excel file by right-clicking on the map and select Export Tables. A new window appears. Select the tables you want to export. Then click on OK and select the destination folder for Excel tables files. In this Excel file, all data for the selected map are reported and can be manipulated through Excel functions.
So as you can see, all the results are in this Excel file, so you could easily read it and check if everything is fine regarding the study report. And then another way is to use MetaPath offshore to check data directly in the database. But again, keep in mind that if you make modification in the database, the modification won't be automatically done in the MSS Composer.
Chapter 2. Description of main MetaPath screen. In this video, the different windows of the main screen will be described. By default, the database opens with the metabolic pathway of the first map in the database. Study info. At the top of the metabolic pathway, you can switch from the map to 3 other tabs which are linked to the same study. In PhysChem Prop, you will find the octanol water partition coefficient of the active substance. Results Met displays tables of data from the metabolism study. It usually summarizes the distribution of the parent and the metabolites in various matrices. Results PK displays pharmacokinetic data of the parent. It contains results for total residues radioactivity, TRR, in the different tested matrices. These data are, however, not available for all the maps. Come back to the tree. List of all maps. On the left of the main screen, you can see the list of all maps within the database, sequentially numbered. Click on any map to show it on the main screen. Blinking blue box and other info. Quick view of the tree. For each map, the parent is initially surrounded by a blinking blue box to show you where the cursor is. Click on any metabolite in the map to expand the file folder showing the metabolite in relation to parent and other metabolites. Tree Map Edition. Just above the tree, you can find a row of buttons that lets you edit the metabolic pathway. The functions are described by hovering over the icon. Basically, you can widen or reduce the size of the scheme, surround or not the molecules with a dark square, add or remove the smile code of the molecules. Click on Map Front to change the typeface. You can copy the scheme and paste it into a Word or PowerPoint file. Or directly print the entire tree by clicking on Print Preview. This will open a tree processing box. Click on Fit to Page or Auto Preview to adjust the margins and print the metabolic scheme. A right mouse click anywhere on the map also brings commands to copy the tree, save it anywhere on your computer in the form of a bitmap, JPEG, or metafile. The Custom Labels checkbox allows you to display the metabolite names if checked, or a simple numbering if not checked. 2D structure. When you click either on the parent or any metabolites in the main screen map view, its two-dimensional structure is displayed on the left lower box. Use the buttons to enlarge or shrink the molecule. You can rotate the chemical around by clicking on any part of the structure, holding down the left mouse button and dragging to rotate the molecule. The third button will open the 2D depiction option box, which allow you to copy the structure and the smile code of the molecule, save the picture on your computer as a graphic image, or change the structure design.
For example, to show the atom number, click on Atom Number, close the box and click on the molecule to see the modifications. Double-click for display options. Below the list of all the maps, a double-click for display options show you the name, the cast number which is only available for the parent, and the smile code used to build the structure of the chemical surrounded by the blinking blue box. Double-click on this table to add or remove information. Connectivity scheme. Below the map, a connectivity table displays the hierarchy of metabolites connected to the parent chemical and to other metabolites. You can show different way of the hierarchy by clicking on the arrow. This scheme can also be copied to the clipboard using a right mouse click.
So now you are probably more familiar with the MSS Composer and how to validate such files in using the MSS Composer, using MetaPath or other way to display information. But I'm sure that you have some question. I already saw some in the QR chat. So if you're okay, even if we are a little bit ahead, we could move to the Q&A session and try to answer all your questions. So first, yes, we also received some question when you made the registration. So thank you. There are a few questions. Charlotte, Opaline, and maybe also our colleague from EFSA will help us to answer. There are some questions about the QR report template. Maybe Charlotte, you could answer, or when we can get the report, or if we okay to share it with the RMS.
Yes, so a question is, where can we find a template for QR reports? So I repeat that this template is a proposition and that you can improve it, but we will be glad to share the QR reports, the proposition with EFSA and RMS. So I think we will send it to EFSA and they will send it to each RMS.
Thank you, Charlotte. There are also preliminary questions on the compatibility of MSS Composer version and MetaPath version. Maybe Opaline, you could share your view on this.
Yeah, sorry, I have to put my microphone. About the compatibility of MetaPath and the MSS Composer, the new version of with the new version of the database, you can use the old version of the MSS Composer and import it them. They will ask you a question. Do you want to convert the database? And if you click on OK, it will convert the old database in a new one.
Thank you, Opaline. We receive also a question on the question is, are the XML files a format that is open by the member state authority in the MSS Composer? So I expect that now you are understand that yes, the XML file is the format to be opened in the MSS Composer, and they review this content of the XML file received from the applicant has to be done by the RMS. The study report needs to be summarized as XML by the applicant. The XML created using the adequate MSS Composer, livestock, crop or plant, and yes, it can be also modified in the MSS Composer with modification reported in the QR report if you want and if needed. And then the XML can be imported in the database, but for that you can check the rules in the user guide as precised by Charlotte and Opaline during this webinar. There is an interesting question also on how the member state can use the information in MetaPath. Maybe Charlotte, you can answer to this.
So, for instance, MetaPath can help to find common metabolites or common substructure or compare pathways. We invite you to watch the video available in the EFSA website. And in the future, further functionality will be enabled to support the risk assessment of metabolites.
Thank you, Charlotte. During the webinar, Opaline, you probably see that there is a question on the submission of when the submission of an XML file is necessary or not in a Euclid. Maybe you could give some information on this.
Yeah. I think I was maybe not really clear about this. So if no study is provided, of course, no XML has to be provided. If a metabolism study has already been populated according to the references provided in list 1 or 2, the EFSA lists, applicants are requested not to create a new XML file. But to report the corresponding individual file number in the Euclid dossier, so in the literature reference of the relevant endpoint study records.
Maybe you want to take the floor again to answer to the question on how or where in Euclid should the XML file can be found.
Yeah. When can we find the XML file in Euclid? So in Euclid, you will find the dossier on the active substance, and then you will find a little picture of a study report. And then when you click on that, you will find in attached documents the XML file.
Thank you. And there is also a question on the Excel file in older MetaPath presentation that a participant has found. Which listed the map already created for the different active substances. Normally, to answer, yes, normally the most up-to-date version of database content is on the EFSA website. So please don't use table in all presentation as they might not be up to date. So it is not necessary to check the database directly, but this could be an option, of course. Please bear in mind that there is a second database called the legacy database that would also have to be checked. At the end of this PowerPoint, we summarize all the document and already available, and specifically the link to find all the document that we have talked about today. So yes, I think it's the last slide of our presentation. I don't know if there is other question. Don't hesitate to post your question. Charlotte and Opaline, if you see other question, please take the floor. I would also ask my colleague from EFSA, Herman and Hanya. Don't hesitate. I think there is a last question about the availability of MSS composer for hydrolysis studies. So for now, no, there is only composer for rat, for plant, rotational crop, plant as a primary crop, rotational crop and animal. But so one day it could be an evolution. So concerning the availability of the presentation that we have done today, the webinar has been recorded, so you can find it in a few weeks, probably in the future weeks, on the EFSA website. We could also share with you the videos that have been created especially for the webinar. And yes, we hope that you receive all the information that you need to validate the XML, that this step is more clear for you now. Maybe I can add that previous in the error occurring in the previous version has been solved for most of them, but yes, you can see on the LMC website the modification performed in the different versions that they have created. So if there is no other question, I'll let my colleague told me if there is. Okay. So yes, before leaving, we'd like to thank you for your participation and to share, and we'd like to share, as I said, useful links for you for the future. You can find all the documents and the links of the EFSA website. For example, the manual describing all the rules to fill the MSS composer, the tutorial video for use of MetaPath, the link to the previous webinar on how to complete MSS, and the list of the map already coded. And as mentioned, there is two lists. One is the regulatory legacy collection of map, and the other one is the EFSA public MetaPath database of maps that could be shared with anyone. So we also like to warmly thank our colleagues from EFSA, especially Carolina, Herman and Marina, for their support for this webinar. So thank you very much for your attending to our event. And in case we did not manage to answer all of your questions, you will find them published on EFSA website. Don't hesitate to also ask your question. The recording will be available, as I already said, in few days or few weeks, I don't really know. EFSA, we will send you an evaluation survey. So please to take a few minutes to fill out. Your feedback is essential to improve your future events. So yes, again, thank you very much. Thank all for your participation, and especially thanks to Charlotte and Opaline who prepare all this webinar with me. And yes, we hope it will be helpful for all of you to populate this database and yes, make it a very useful tool for risk assessment in the future.